All right, and welcome back to part 3 of our Introduction to Hyper-V Jumpstart. In this module, we're going to be focusing on Hyper-V networking. But first, I want to remind all of our live attendees to check out the poll and to please use the Q&A. We have some great people answering Q&A, some of my fellow evangelists from around the world, including Keith, Kevin, Dan, Rick. We have some people from our engineering product group, such as Brian, and then some great MVPs like Nirmal and Patrick. So please ask anything you want. We'll take questions live. Remember, this is a great opportunity for you to learn everything you want to know about Hyper-V from the experts. So turning it over to the expert of experts.
Oh, thank you.
Networking guru, take it away.
Thanks, everyone. So let's get to Hyper-V networking. So in this session, I want to talk about a number of things such as virtual networks, software-defined networking, the new Hyper-V Extensible Switch, NIC teaming, guesswork network load balancing, and plenty more. So let's start with virtual networks for just a second. So when it comes to virtual networking, we implement a virtual switch. And in Server 2008 and 2008 R2 Hyper-V, the virtual switch was pretty much a very basic unmanaged switch. Think of it as, an unmanaged switch with VLANs for logical segmentation. It obviously is a switch, so it learns port to MAC mappings, doesn't implement spanning trees, implement layer 3. That's kind of where we've been with Server 2000 and 2008 R2. In 2012, as a result of listening to what you asked for and wanting additional capabilities in 2012 in terms of the virtual switch, we realized there's a tremendous amount of value in the virtual switch that we wanted to provide not only to you in the included built-in switch, but also to make it available to our partners out here who are now fully taking advantage. And there's a whole bunch of solutions now that are plugging into 2012 and more on the way. So let's get started. A couple things to understand about virtual networks. You can create virtual networks. In fact, let me switch on over here to Hyper-V Manager for just a moment. Again, I'm going to go back and use the Hyper-V Virtual Manager. This is all using the UI built directly into Server 2012. You'll see here on the right-hand side, we've got Hyper-V settings. We've got the Virtual Switch Manager. Here is where you basically configure your switches for the virtual machine. Now, I've got one here already running. This is my external. This is generally my general CorpNet switch. You can see that it is attached to this specific physical NIC and that the management operating system is actually sharing this network adapter. And in fact, I've also got the ability to plug in extensions, such as into the Windows filtering platform, NDIS capturing, as well as other third parties can plug into this. And I'll get back to the extensibility in just a moment. But if I want to create a new virtual switch, you can see there's different types of virtual switches. There's an external switch, an internal, and a private. So let's go with an internal switch. Well, what does that mean exactly? Well, an internal switch means that the management partition on the system, as well as all of the virtual machines, can participate amongst themselves. No packets actually go out over the wire, but it's among all of the virtual machines as well as the management partition, the parent partition we call it, that's running on the system. If I wanted to create a purely private network, so I could create a purely private network and any VMs that I attach to the private network can communicate with each other. Nothing goes out over the wire, nothing even talks to the management partition, it simply goes among each other. This is great, for example, in a test dev environment or in a development environment. So for example, you want to create a multi-tier application, you want to test it, and maybe you're on a plane on your laptop and you want to create a multi-tier environment, you want to create a private network, you can easily do that. Again, internal network provides you the ability for your virtual machines and the management partition to participate. And an external network means it literally is anything that's plugged into the physical wire it is potentially access to. And of course, we've got VLAN identification for the management operating system. And I'll get back to more on VLANs in just a second. So those are some of the difference between the different types of networks that are available in Hyper-V. There's two different types of network adapters. There's the synthetic network adapter and the emulated adapter. Let me make this very, very simple. Always use the synthetic network adapter. Always. Okay. There's one case you're going to use the emulated. There's literally one case where you use emulated, and that's for Pixie Boot. Okay, all the operating systems that we support today, whether it's Windows or Linux or other operating systems like FreeBSD, for example, those operating systems, we include a high-speed network driver. So you always want to use a synthetic network adapter. The only case is if you're in some environment where you need to PXE boot, that'll be the one case where you use the legacy emulated driver. The reason why is performance, performance, performance. With the synthetic network adapter, we can drive massive performance. You want to get plus 10 gigabits into a virtual machine, you're going to do it through the synthetic network adapter. You want to take advantage of VMQ and additional also performance enhancements. Those are also going to happen with the synthetic network adapter. Think of the emulated as PXE only. I'm going to keep it that simple. When it comes to network considerations, you gave us a bunch of feedback. How do I ensure network multi-tenancy? So for example, very often someone would say, I'm a service provider, I'm a cloud provider, I want to provide Woodgrove Bank and Contoso Bank. These are two different banks, but what if their virtual machines happen to be running on the same server? How do I make sure that they're completely isolated from each other with logical segmentation? What if VMs are competing for bandwidth? Okay, you know, I've got a really important SQL server and I've got a really not so important print server. What if I want to make sure that SQL Server is never starved for bandwidth? How do I deal with that? What are the strategies I can employ? What are the features that you can help me with to provide that? How do I fully leverage and how do I integrate with the existing network fabric? Can you take advantage of hardware offloads? Can I get the absolute best possible performance? Can you make sure that any enhancements that are happening in silicon, we can really fully leverage in the virtualization layer and in the virtual switch itself? What if I want to take, that large scale-up workload that we've talked about previously, these large scale-up workloads that have had, multiple 10 gigabit NIC needs. They have really low latency, high throughput requirements. I need to give them 10 plus gigabit performance into a VM. Is that even possible? Can I essentially dedicate a physical NIC into a virtual machine? So these are a bunch of considerations, bunch of questions that we heard as we were in planning and development for Server 2012. Another thing was about reliability. When you're designing a private cloud, you want to make sure that even if the hardware fails, there's always redundancy there. So you want to make sure you want teaming. Customers want continuous availability. If a NIC fails, and NICs do fail, if someone unplugs the wrong cable, that happens as well. You want to make sure that your network continues to go right along, and you also want to be able to take advantage of aggregation as well. In addition to reliability, there's predictability. So for example, again, going back to my super important SQL and my print server, my SQL server could be the most important workload. It's the core of my infrastructure. It's what's running my business. I want to make sure this thing is never, ever starved for resources. How do I ensure that that never becomes an issue? So that competing for bandwidth. Also, if I'm in a service provider situation, perhaps I'm charging based on network connectivity. So for example, maybe someone has decided they want the silver level service. Silver level gives them 10 megabits. Maybe gold gives them 25 or 50 megabits. Platinum gives them 100 megabits. How do you make sure that you have a quality of service that can meet that service level agreement? That's a key challenge, whether it's building your own private cloud or offering it as a service provider. So a lot of different challenges that folks have when it comes to that. And of course, in a multi-tenant environment, you expect security and isolation. So one of the biggest challenges that we heard from large enterprises as well as service providers really around the world were, how do you deal with multi-tenancy? So I want to create a large pooled infrastructure, okay? I want to pool my storage, my networking, my compute, and all of this, and I want to be able to basically put workloads on there, but at the same time, I need to be able to provide multi-tenancy from a networking layer. Now, traditionally, it's been VLANs. So for example, if I'm a service, if I'm running an internal cloud, maybe one division gets VLAN 1 or another customer gets VLAN 2 or another customer gets VLAN 3, and you just provision out VLANs. VLANs were a great solution in 1995. They don't scale to the requirements that we have with VLANs today. Couple of challenges. First of all, tenants want to easily move VMs to and from the cloud. Maybe that's a VLAN. Maybe it's I need to change an IP address. That can be a challenge, if not an impossibility for many customers to say, wait a minute. If I want to take a workload running here on my local infrastructure and move it to a service provider, you're going to tell me I need to change the IP address? that may not ever happen. This could be a workload that's been here at the company longer than I have, and no amount of cajoling is going to get me to change this IP address. We've got servers throughout my infrastructure that are doing reporting, looking for a specific IP address. I'm not going to change it. So tenants want to easily move those VMs to and from the cloud. As the hoster, or the person at the organization providing the private cloud, I also want the ability to place VMs anywhere in my data center. So for example, if I take a VM from a customer and I'm running it on rack 1, but you know what? Rack 1 is about to get deprecated because I just bought a whole bunch of new racks and I want to move them over to the new racks. If I can't move it off that rack 1 because it's running in a different network location or it gets pinned by its network identification, that can be a real challenge. So really, hosters want to be able to place VMs anywhere in their data center. So at the end of the day, what you really both want is you want easy onboarding, flexibility, and isolation. And additionally, you have to be able to deal with the challenges of IP addresses and IP collisions in the cloud. So for example, if Contoso is running 10.1.0.0 and Woodgrove is running that as well, I want to be able to bring those into my environment and without them changing their IP address. And I could very well tell them, by the way, I'm already using 10.1.0.0, so you're going to have to change your IP address anyways. And that's not a situation you want to occur. So a couple of things that we looked at ways to enhance this multi-tenancy with Hyper-V was the introduction of PVLANs. PVLANs are very common, especially for web hosting. There's both isolation and community scenarios. It still has limited scalability. It's still going to be limited. You're not going to get, if you want to run massive cloud hosting, it's still going to have its own inherent limitations. But for many classes of customers, PVLAN can be a great solution as well. But we've kind of been looking at this in a much bigger and grander scheme. In fact, what's been interesting is the last 18 months, everyone's been talking about software-defined networking. It's been great to hear how everyone's talking about this as the next new revolutionary technology capability. It's going to give you everything: better gas mileage, your hair will grow back. I mean, it's going to fix all of the world's ills, and everyone's talking about it as a brand new technology that no one's ever done before. What's interesting is actually we've been doing it at Microsoft for a long time. Software-defined networking is something we've learned from running global services around the world. When you're running Hotmail, when you're running Bing, when you're running Outlook.com, when you're running Xbox, when you're running Azure, we know the complexity involved with managing all of these virtual networks, logical segmentation. So software-defined networking is something we're very keenly aware of, which is why we built this capability right into Server 2012. This isn't an add-on. This isn't something you have to buy as an extra. It's actually network virtualization as well as virtual switch extensibility that's part and parcel of the platform. What this allows us to do is to create virtual networks that run on top of the physical network. So think about virtual machines for a second. With virtual machines, how do virtual machines work? Well, you've got a physical server. A physical server has a specific type of processor with a physical NIC, with amount of memory. It's got physical HBAs. It's got all these physical attributes. We then abstract that and create a virtual machine. That virtual machine running atop that has virtual hardware that we present. It has the Microsoft storage adapters, it has Microsoft network adapters, it has Microsoft video adapter, and we present that in the virtual machine. By abstracting the virtual machine from the physical layer, it now gives us the ability to do all sorts of things with that virtual machine. I can move it, I can decouple it from the physical layer, and it allows me to do live migration, it allows me to make changes, it allows me to actually do things in a virtual world that I can't do in a physical world and be more pliable and elastic with the workload itself. What if we take those same concepts, those same attributes, and apply that to the network? So what we want to do is, we certainly understand that there's a physical network, but what if we create a logical network that's abstracted from the physical layer? Well, now we can take advantages of those same concepts, those same core tenets that we had with virtual machines, and apply it to a network. So now, for example, we can create policies that span physical and virtual networks. We can do things that you could never do before. For example, what if you want to live migrate across a physical subnet? You can't do it. There's no way to do it today because by definition, crossing a physical subnet is going to create a disruption. Well, not with software-defined networking, where we're creating a logical network atop the physical fabric. So the problem solved by this is we're removing VLAN constraints. What I mean by that is VLANs have up to 4,095 VLANs in the VLAN spec. That may not sound like a limit. Trust me, we've run into folks where it's actually a very big challenge. I was actually recently talking with customers around the world, and one of the questions I would ask them is, how many VLANs do you have in your infrastructure? Very commonly, the answer was dozens or hundreds, and one of them couldn't even tell me. They weren't even sure if it was hundreds or thousands. So we know that as corporations grow, as enterprises grow, network management can become difficult, and VLANs can become a huge management pain point. So it removes VLAN constraints. It allows us to configure security policies that limit the type of traffic, eliminates hierarchical IP addresses, allows us to create big flat networks. So the way we're doing this is through GRE, generic routing and encapsulation. And honestly, this is an hour, 2-hour talk in and of itself, so I'm going to point you to a whole bunch of online materials. But a couple things I want you to understand about NVGRE and why we've chosen this. Number one, it's defined by public standards, RFC 2784 and RFC 2890. So this isn't a Microsoft proprietary spec. In fact, the industry is very much involved in this. So you don't have to worry about something going down a path that others aren't going to take. They're already taking it. What's nice about GRE is one customer address per virtual machine. So there's an address on per VM as well as a provider address per host. What this allows us to do is allows us to be, again, more flexible in terms of how we deploy and in terms of a multi-tenancy for the virtual machine. So at a very, very precise example, I can literally have a physical server now that has 2 virtual machines running on top of that. Those 2 virtual machines can have the same exact IP address. They could both have 10.1.1.11 and be running on the same physical server. They can see all of their north-south traffic, they can see all of their east-west traffic, but they can't see each other because they're logically segmented through network virtualization. So it gives you the multi-tenancy, it gives you the isolation. It also gives you the ability now to move virtual machines freely throughout my infrastructure if I'm a cloud provider, or to and from a cloud provider, because I can now do it and traverse physical subnets without downtime. This lowers the burden on switches. It allows traffic analysis, metering, and control. The other thing I get asked is, well, what if I still like my VLANs? Can I run a VLAN on top of network virtualization? Absolutely, because it is transparent. So VLANs can run on top of network virtualization, and it's completely transparent to the whole to VLANs. So generic routing and encapsulation and network virtualization. Again, this is a key part of how we think of software-defined networking, and it's part of the platform built into Server 2012. Now, another key part of software-defined networking is also the ability to give you the flexibility, the choice, and the extensibility you're looking for. One of the things customers told us is, look, we want to be able to deploy based on our business needs. So for example, maybe if I'm in a branch office, I really would like to have a virtual firewall. I'd like to be able to route everything through a virtual firewall through different types of network appliances. If I'm a data center, maybe I want to be able to manage all of my virtual switches in a way that's consistent with how I manage my physical switches. So these are important different business decisions and business requirements based on your needs. So we really took a good look at how we could provide this extensibility. And there's a number of ways you can actually provide an extensible switch. And we looked at a couple different ways. One is to basically provide a closed replaceable switch. In that case, you've got a virtual switch, and then you basically pull it out and drop in a different one. And it's in an either-or situation. And we certainly could have done that. But we decided what we really wanted to do was provide a lot of flexibility and choice, which is why we developed the HyperV Extensible Switch. The HyperV Extensible Switch is an open flexible switch. And what I mean by that as an open extensible switch is this. Here's a diagram talking about the virtual machines and how they're plugged in to the virtual switch. So in this case, I've got 2 virtual machines. They have virtual NICs assigned to them, and they are going through the extensible switch. So let's say for just a moment, I would like to be able to capture extensions. I would like to be able to inspect traffic as it traverses the virtual switch. I just want to be able to monitor it. I want to be able to generate reports. I don't want to modify anything. I just want to do capturing extensions. Okay, we've got solutions that are out there right now. For example, SFlow by Inmon. And so you can plug in as a capture extension. Well, what if you want to do something a little bit more interesting than that? For example, you'd like to insert packets, you'd like to drop packets, you'd like to filter packets, you'd like to inspect packets. This is the perfect place to do intrusion detection, anti-malware, antivirus, all sorts of interesting things into the virtual switch. Well, guess what? We have that as well with the Windows Filtering Platform, or WFP. And in fact, we've got 5.9 that delivers a virtual firewall that plugs right into the HyperV Extensible switch. So again, think about that branch office scenario where you've got someone who says, look, I've got a branch office and I want a simple firewall to help me protect all my branch offices. This gives you that flexibility to do that. Finally, you may be thinking, well, I'm in a data center, and maybe I'm a Cisco shop, and I would like to be able to manage my virtual switches just like I manage my Cisco switches. Well, Cisco has the Nexus 1000V for Hyper-V. So that gives me the ability to use my same network management tools to manage my virtual switches with Hyper-V by using the Cisco Nexus 1000V. Or, as recently announced by NEC, the first open-flow programmable virtual switch is now available, and it's for Hyper-V. NEC has released this and allows you to plug right in. So OpenFlow is something that's been garnering a lot of popularity, especially in Asia Pacific and Europe. We've seen a lot of interest there, but it's kind of growing all around. And OpenFlow is something that's available right now as a switch extension into Hyper-V. Finally, the one thing I want to point out here is also you can mix and match these. So you may look at these and go, you know, Jeff, this is really cool, but I'd like to use the SFlow by Inmon to do capturing as well as use the Cisco Nexus 1000V. Well, guess what? You can do that. So you can actually use these in tandem simultaneously based on your business needs. So this gives you flexibility and the extensibility you're looking for. Finally, you may look at this and go, wow, this is really great, but guess what? I need something that is not provided by any of these vendors. I have something very unique to my infrastructure. I want to look for some very specific packet sequence. I have some very unique requirement in my networking infrastructure. None of these have that. Okay, guess what? You can write your own switch extension. So like I said, it's open and extensible. So in fact, if you have Windows 8 and you're running Hyper-V on your tablet or your desktop or your laptop, guess what? You have the open extensible switch on your client system. So you can write switch extensions for on client and deploy those on server. So we really thought about this holistically, giving our developers and our IT pros the ability to take advantage of this even in their own portable dev and lab and test environments, and then deploy those in server. So we're very excited about what the extensible switch brings to Hyper-V in 2012.
Now, let me jump in and ask a question, because I've seen this one come up a lot already. What is the best practice for the number of networks for a host?
Wow, that is a
open-ended question,
yeah,
right?
Very
Lots
open,
of answers there.
Very open question, and I wish there was one answer I could give you. It really depends on your deployment. Let's keep it real simple. Let me put it to you in a different way. If I was to build a network today, if I was to build a server today, what would I do? I would make sure that every server has at least two 10 gig NICs. Because with what we've done in Server 2012, you can now team them together, and then you can just carve them up. Okay, so you can now carve them up into networks for your virtual machine, networking for live migration traffic, networking for cluster heartbeat, networking for storage. So for example, if you're using iSCSI, or if you're using SMB for file server, you could do that. So in a perfect world, if someone said, Jeff, if you're to start today, what would you use? I would go with a server, put in two 10 gig NICs, use the Windows NIC teaming in the box, and then dice and slice appropriately. Now, I don't want you to think that that's the only way to do it, because guess what? I know there are plenty of SMBs out there, small, medium business out there that say, I can't afford a new server with two 10 gig NICs. All I've got is gigabit. Gigabit's great as well. And in fact, we have best practices. If you go to technet.microsoft.com, we get this question asked a lot, and actually walk you through the different configurations out there. I've got 2 gigabit NICs, or I've got 3 gigabit NICs, or I've got 4 gigabit NICs, or I've got 4 gigabit NICs and a 10 gig, etc. But what it does is it actually walks you through the different ways to configure your system. It really depends on your infrastructure. So for example, if you're doing storage over the network through iSCSI or SMB, then you're going to want to make sure that, for example, you're going to dedicate connectivity to iSCSI. You're not going to want your iSCSI connectivity sharing it with your general networking. You're going to want to be able to give it its own dedicated bandwidth. And like I said, In a perfect world, where someone said, I've got brand new storage, brand new hardware, and I can do whatever I'd like, I'd certainly go with two 10 gigabit NICs and then team them, and then I can carve them all up in software and take advantage of all of that in Server 2012.
And as always, you want two of everything for redundancy. So best practice, two NICs, two servers, two everything throughout the stack.
Redundancy is definitely the name of the game for a best practice. I always, remind everyone, in a test lab environment, redundancy may not be a big deal, okay, but in production, don't cut the corners, folks. Make sure you've got redundancy and you've got the resiliency throughout the entire stack, whether it's storage, whether it's networking, whether it's clustering, and I'll get to resiliency throughout the entire stack in just a bit. So when it comes to networking in the box, like I said, we've got an open extensible virtual switch, which has enabled a whole bunch of things like Nexus 1000, OpenFlow network introspection, much, much more. Advanced networking like ACLs, PVLANs, trunking, all of these things here, those are all part and parcel of the Server 2012 virtual switch. NIC teaming, a key capability. I cannot say enough about NIC teaming. I love the new NIC teaming in the box. It's real simple, and one of the main advantages is we've seen a lot of siloed NICs in the past. So generally what will happen is someone will buy a server, and server comes with NIC A on the motherboard. And someone goes, great, I need some more NICs. So they buy another NIC, but NIC B is made by a different company. And so you want to team these together. Company A says, sorry, I won't support you if you team it with Company B. Company B says, I won't support you if you team it with Company A. So what ends up happening is you've got these siloed NICs that can't be used or can't be teamed. With Server 2012, you can team all these together. In fact, I was talking with one of the program managers throughout development, and they had servers in their labs with 8 different NICs from 8 different vendors, all teamed, and it all just works. And if you have a question, you call us. We'll get it all taken care of. So NIC teaming, great inbox solution. Network QoS. So network QoS, and in fact, on a very granular per VNIC capabilities there, and I'll show you that in a second, as well as network metering, dynamic virtual machine queues, and SRIO. So one of the things we really focused on, I'm going to go back to the scale that I've talked about earlier, which is we wanted to be able to virtualize everything. That was exactly what you told us. And again, a lot of these cases, when it came to these scale-up workloads, was making sure that we had a balanced system. So we've given you NUMA, we've given you massive virtual processors, we've given you massive memory. Now how do we make sure that from a networking standpoint, we can keep these virtual machines busy and keep that I/O humming along? So there's a couple ways you can do it. Virtual machine queue, and another way is SRIO.
Now, let me just ask one really quick question. You mentioned QoS. Can you define that? Explain what QoS is? QoS
is quality of service. So you want to be able to assign minimums and maximums and really be able to determine how much of a pipe can you allocate to, how much of a resource can you allocate so that you can meet a service level agreement. If you're a service provider, quite simply, this is how you do business. You'll get a silver level, support level agreement where you say, I'm going to give you X amount of networking or X amount of memory or X amount of CPU time, and you've got to make sure that you meet that service level agreement. So quality of service is a key capability that allows you to meet that metric. So when it comes to providing high performance networking, so one thing I wanted, again, it was going back to those really massive scale-up workloads. And in fact, to be very clear, we run into folks that say, look, I've got this massive SQL database. This thing has 2 10 gigabit NICs, it's teamed for redundancy, and we're pushing 20 gigs, 20 gigabits into the physical machine. If I'm going to put this into a virtual machine, I need to make sure that I can get that same level of performance. Just because I'm going to virtualize doesn't mean all of a sudden I'm going to take some huge drop in performance. B, I want to be able to provide that level of redundancy because I was doing teaming before. I expect to be able to team it, but also because one of the reasons I want to be able to move it into a VM is because I want it to be able to live migrate. I want to be able to take advantage and move this virtual machine from server to server, and I want to be able to take advantage of the best of both worlds. So how do you do that? That's an incredibly difficult challenge. And it all starts with a capability called SRIO, or Single Root I/O Virtualization. So generally, the way networking works is in a virtual machine, the virtual machine I/O goes to the virtual network stack within the guest operating system to the virtual NIC. The virtual NIC then communicates with the virtual switch, and the virtual switch determines where do those packets go. Do they go to another VM that's attached to the machine, or do they actually go to the physical NIC and out to the physical layer? Well, again, they traverse through the NIC, but again, to really give you the absolute best performance for high throughput, low latency applications like these massive scale-up SQL servers, what we really want to do is actually allocate a portion of the NIC into the virtual machine, and that's exactly what SRIOV does. With SRIOV, we're actually assigning a portion of the NIC into the VM. And what do I mean by a portion of it? Well, we basically divide a NIC into two parts. There's the control plane and the data plane. The control plane is how you're actually allocating and assigning and managing the physical NIC itself. The data plane is where all the data is traversing from the virtual machine into the, to the I/O, to the physical fabric. So the control plane lives in the management interface in Hyper-V. The data plane allows us to actually take a virtual machine and allocate a NIC into the VM. That's right, into the VM itself. So what this means is, for the first time ever, you go into Device Manager and you actually see it says, oh, this is an Intel NIC, or this is a Broadcom NIC, or this is an actual physical NIC. You see it within the VM. So the way this works is, number one, it reduces the latency of network path, because it now it doesn't traverse the virtual switch, it goes directly to the physical NIC. So if you see here in this diagram, the way virtual machines normally work is I/O goes to the virtual NIC communicates to the switch then communicates down to the physical NIC. With SRIOV, it changes. With the SRIOV, we actually create a virtual function, and that virtual function is communicating directly with the physical NIC. So what this means is now I/O is not going through the virtual switch. So what this means is we can get native 10 gigabit line performance into a VM. So this gives us massive performance, super low latency, high throughput. Also, it reduces CPU utilization, because these packets now don't need to be processed in the root partition, because it's actually the virtual machine communicating with the physical NIC. Now, the big challenge is this last bullet item here, supports live migration. Because as you told us very loudly, live migration is something you expect in all cases. And in fact, we made sure that every feature in Server 2012 Hyper-V works with live migration without exception. This is probably one of, if not the hardest challenge we had to solve when it comes to making that promise and keeping that promise to you, which is how you do SRIOV and live migration. So let me actually walk you through the entire process so you understand. So the way it works is, number one, let's just suppose you enable to SRIOV. So the way that works is, again, we enable the virtual function and map it into the virtual machine. So we then create, and it's in quotes, this kind of lightweight team. And it is in quotes because it's actually using a very super lightweight team in the NIC itself. It's not the Windows NIC team, it's even lighter weight than that. And what we do is we essentially make sure that the traffic for the network is going through the virtual function down to the SRIOV physical NIC. Now, the software switch is there, but we're actually not using it, but we're keeping this lightweight team. Now, suppose I'm running a virtual machine on this physical server with SRIOV, and I want to be able to live migrate it to another VM. Well, number one, I have to deal with all sorts of error conditions and all sorts of conditions that could happen in the real world. What if I want to live migrate this to another machine, and the other machine doesn't have SRIOV? What if I want to live migrate this to another virtual machine, or it has our SRIOV, but all of those resources are already used up? How do I deal with all of those different challenges? So there's lots of different edge cases and corner cases that we need to understand. So the way live migration works with SRIOV is we've got it running on the source machine. As we live migrate it to the target, we break this quote-unquote lightweight team. We then remove the virtual function from the virtual machine. During this time, all of the network traffic continues to go through the software NIC, continues to go through the software switch. We then live migrate the VM the way we normally do. We assign it to the new, we live migrate it to the new target. We then reassign the virtual function, and we assume the resources are available, and we keep running, and now we provide SRIOV on the target. Now again, we have to deal with all sorts of interesting conditions. What if, for example, I don't have enough resources, or I need to live migrate it to a server that doesn't have SRIOV? The last thing we want is for you to see a dialog that says, sorry, you can't live migrate this VM because it doesn't have SRIOV, or there's not enough resources available, or insert random condition here. Because what if you're in an emergency case and you need to get these VMs off, and you're willing to accept, you know what, I need to move it off to this machine that doesn't have SRIOV, but at least it'll stay up. Okay, so we made sure that we meet all of those conditions. So that capability is all of there, and this is all done transparently through SRIOV and live migration. So one thing to point out is some of the other capabilities to improve performance and scale. One of these is what we call dynamic virtual machine queues, or DVMQ. So SRIOV, one of the things I get asked about when people see SRIOV go, wow, this is fantastic. Should I just use this for everything? You know, should I just deploy this on everything? No. That's really overkill. Think about SRIOV as really for those scale-up workloads, those workloads that really have demanding, again, high throughput, especially low latency, maybe VoIP applications, for example, or that massive scale-up SQL server. If you need 10 plus gigabit NIC performance in a VM, SRIOV is going to be the way to do it. However, for pretty much everything else, the best way to do it is DVMQ. DVMQ is an acceleration method that we use that's in a lot of network adapters today, and will get you easily up to about 9 gigabits, which is pretty much what, meets the vast majority of workloads out there. You don't need SRIOV for a print server, okay? It's going to be overkill for a whole bunch of things out there. DVMQ is actually enabled by default. And so what are the pros and cons to using each of these? Well, DVMQ gives you improved VM performance. It actually allows you to use receive-side scaling benefits. For example, it'll spread network load across multiple logical processors. So it gives you RSS-type capabilities. It allows you to use the Extensible Switch. So if you want to use, for example, the 5.9 virtual firewall, if you want to use the Inmon, you want to monitor traffic, you want to use the Cisco Nexus or the NEC OpenFlow, you can use the DVMQ hardware acceleration, give you great performance, and still get all of these extensible switch capabilities. Really, it's if that application needs more than 10 gigabits, do you really want to consider SRIOV? The big thing to keep in mind with SRIOV, yeah, it's great for 10 gigabit plus, but here's the thing that you have to remember. It's going to bypass the switch. Okay? So remember, it's a choice you're making. If you decide, you know what, I want 10 plus 20 gigabits into a virtual machine, and I want to be able to still live migrate, but I need that exceptional performance, and SRIOV is the way to do it. But keep in mind, it's not going to go through the switch. You're not going to be able to manage, you're not going to be able to take advantage of the extensible switch and the capabilities there. Or, for example, quality of service capabilities. You're not going to be able to do that as well there because it's going directly to the physical NIC.
Now, I have a question from the audience here. Is there any limitation for what type of switches can use this? Obviously, they need to be capable, but must it be a 10 gigabyte switch?
No. There are no special considerations switch side. These are all considerations. That's a great question. The considerations are really NIC side. So what you need to look out, and here are a couple of things. It's very often it's kind of difficult to get this information from the vendors. So for example, SRIOV has basically has SRIOV resources, and maybe the early NICs supported 8 channels of SRIOV. The newer ones may support 32 channels of SRIOV at 64. So the more channels that are available on the NIC gives you more options for SRIOV and more VMs that can take advantage of it. So that's something to think about. DVMQ, virtual machine queues, also have the same thing. So early DVMQ NICs supported, say, 8 or 16. Now newer ones you see 32 and 64 to allow you to accelerate these things. So gives you allows you to provide more VMs with this capability, but it really is a NIC capability. Switch side, you don't need to worry about any of that. So let's actually dive into some of the new switch capabilities and to some of the new NIC capabilities that are built into Windows Server 2012. So go back over here to the HyperV Manager. And first of all, we talked about the switch earlier. So let's go in here to the virtual network adapter. And you can see here, I've got a VM, and I'm going to go ahead and attach it to this virtual switch. Click Apply. So VLANs, you can see we've got VLANs, and we've had VLANs around for a long time. It's an easy way to do logical segmentation. Those are still here. But let's get to quality of service. Highly requested feature, bandwidth management. So think about this for a second. I used this example before. Say, for example, you've got a SQL server. This SQL server, extremely important. This is what's running my business. This is extremely important that it's never starved for network bandwidth. So you want to make sure at a minimum, you know what, this gets half a gigabit NIC at all times. It gets 512 megabits, done. On the other hand, what if this is my print server? Okay, I know that every Friday the guys in the graphics department like to print out these huge posters and consume a whole bunch of network traffic. Now, maybe that's fine, but you know what? If it takes them a little bit longer, that's not going to impact the business. So you know what? I'm going to actually provide them a maximum of 100 megabits. So yeah, it may take them a little bit longer, but that's okay because it's not going to completely saturate my network. And you can see I'm doing this all very easily, typing these into the UI. Everything I've been showing, by the way, everything I've been showing through Hyper-V can all be done through PowerShell automation. So if you wanted to create a whole bunch of VMs and create them with default bandwidth management settings, you could do all of that through PowerShell. And of course, all of these can be templated through VMM. So bandwidth management, a key capability in Server 2012. Now, if you'll notice, in 2012, we had so many features that we couldn't even put it on a single pane anymore. So if you go to the hardware acceleration, you'll see we've got a whole bunch of new capabilities. For example, we've got virtual machine queue, we've got IPSec task offload, and SRIO. Now, by default, VMQ is enabled. So if you have a physical NIC that supports VMQ, we'll automatically do the right thing. We'll take advantage of it. It lowers your CPU utilization, takes advantage of the acceleration provided by the virtual NIC, and automatically does the right thing. If your physical NIC doesn't support VMQ, no problem. We simply do it the way we've always done it in software, and if and when you decide to upgrade to VMQ, it's already there. Another thing that we've been seeing a rising in adoption is IPSec. So as we move to private cloud and we move to cloud everywhere, people are very much concerned about encryption and on the wire. And they're looking at, IPSec is a great way to do end-to-end encryption without making any, changes or requirements in the application. I can just do that end-to-end and all my traffic across the wire is encrypted. Now, in the past, if you wanted to do IPSec with Hyper-V, you can absolutely do it. You could do IPSec, but we would have to do the encryption and decryption in the virtual machine itself. So it's not a huge overhead, but it can be a couple percentage points. Well, if you're running 20, 30, 50, 100, etc. VMs, it's all additive. And so you're doing a whole bunch of encryption and decryption. So in Server 2012, we've introduced IPSec task offload. So if your NIC supports the ability to do the encryption and decryption on the NIC, we'll automatically take advantage of that as well for you. So this, again, allows you to take advantage of the latest advances in silicon. You still get the end-to-end encryption, and it's all done very, very quickly. Gives you better performance and scale. And again, if it doesn't support, your NIC doesn't support IPSec task offload, then we'll do it in software just like we always have. Now, I talked about SRIO. So if I want to enable SRIO and I want to provide I want to provide a virtual NIC that's going to talk directly to my physical NIC and give me, that massive 10 plus gigabit performance in here. You're going to enable SRIO here in the virtual NIC. So that's where that's located. By default, SRIO is not enabled. Like I said before, VMQ is actually the best way to go for 99% of your workloads out there. For those scale-up workloads, then you're going to want to consider SRIO. Finally, let's get to some new and advanced features. So MAC address spoofing is something that we've had for quite a while. In fact, this is a question, I don't know if we've gotten it yet on the through the message board yet, but this is a question I get asked quite a bit. What is MAC address spoofing and why is this even here? And it's off by it's off by default. Well, so first of all, the reason why MAC address is spoofing here is if you're using network load balancing. So if you're doing network load balancing, the way network load balancing works is it has to actually mucks around with MAC addresses. And so with MAC address spoofing, it needs that ability to be able to change those MAC addresses. Well, if you're not using it, if you're not using network load balancing, we want this off by default, which is why it's off by default. You don't want to be able to automatically change your MAC address. But if you are using NLB, then you're going to want to enable and check this checkbox. This allows NLB to do the magic it needs to be able to do to manipulate MAC addresses to give you load balancing across virtual machines. So here's the important thing to understand. Enable MAC address spoofing works across virtual machines. So if I've got 2 or 3 or more virtual machines and I need to be able to enable MAC address spoofing and they may actually be using some in common, that's what MAC address spoofing is for. And I'll explain why I'm underlining this in just one second. In addition, we also put some security features in here. So one of the things that are both internal organizations building private clouds as well as service providers told us is, look, are there any additional features that you can give us to help us from a security perspective? And one thing I like to remind folks is, look, the bad guys have credit cards too. There's no reason why I can't go to a service provider, get a VM provision to me that maybe has, Windows Server, but then I put my own OS or I put my own malware in there and I pretend to be a DHCP server or I pretend to be a router. And why would I want to do that? Well, because I'm trying to figure out what's going on in the network and see if I can sniff packets and see if I can actually get data from other VMs or other hosts that are residing on the network. So with DHCP Guard, this actually drops DHCP server messages. So if I set up a VM that's pretending to be a DHCP server, it won't send DHCP authorizations out there, and it'll inhibit those from pretending to be DHCP servers. Another one that really goes hand in hand with that is Router Guard. So for example, I may create a VM and pretend to be a router, sending out router advertisements. So again, if I'm running my own cloud and I want to make sure, look, I know who should be setting up DHCP servers, I know who should be setting up virtual routers, this could be on by default to make sure that no one can actually be out there pretending to do that. So these are some really additional great security features that are simply included part and parcel in the built-in virtual switch. Again, everything I'm showing you here is all built into the existing switch. Another thing that was been asked over some time has been, generally it's called promiscuous mode. It's incorrectly asked, but basically what people are looking for is the ability to do port mirroring. So I want to be able to monitor incoming and outgoing packets and forward those to another virtual machine so I can do packet inspection. So I want to do debugging, maybe performance analysis, maybe trace logging, things like that. So port mirroring is in here. You can set up a VM to be a destination or a source. Again, very quickly and easily here, all included in the built-in switch. Finally, we get down to NIC teaming. So not only do we do host-side NIC teaming in Server 2012, we can do guest-side NIC teaming. Now you may be thinking, hold it, why would I do guest-side NIC teaming? What's the importance of guest-side NIC teaming? Why wouldn't I just do host-side NIC teaming? Well, for most cases, you are going to do host-side NIC teaming because it's all going to be going through the virtual switch. The virtual switch is going to be configured with a couple of NICs configured for teaming. So if there are any sort of outages, the virtual switch continues right along. Remember I talked about SRIOV? And SRIOV bypasses the virtual switch. SRIOV talks directly to the data plane of the SRIOV NIC. So in those cases, you're going to want to configure guest NIC teaming when you're using SRIOV. So if you want to do that, you would be running a virtual machine, you would be running 2 NICs with SRIOV enabled, and you would enable NIC teaming. And the important thing to understand is you need to enable this, because with NIC teaming, this allows us to mux around with the MAC addresses, because the NIC teaming drivers need to do, the NIC teaming software needs to do this to be able to provide the NIC teaming capabilities. Now, if you heard me just a minute ago, I talked about muxing with MAC addresses, but that was in terms of MAC address spoofing. So, what's the difference between MAC address spoofing and NIC teaming? Here's the difference. If you're using NIC teaming, we're allowing you to manipulate MAC addresses for NICs attached to the same virtual machine. If you want to do network load balancing, you want to manipulate MAC addresses between different NICs across different VMs. So there's 2 very different use cases for using MAC address spoofing as well as guest NIC teaming. So if you're doing guest NIC teaming, please, you must enable this checkbox. If you don't, you're not going to actually be taking advantage of NIC teaming. It may look like it's working, but it won't, because it can't actually do the work it needs to do to manipulate the MAC addresses. So a whole bunch of new capabilities all introduced here in Windows Server 2012 when it comes to networking. All right, so me switch ahead. I already went through all of those capabilities. We talked about network load balancing, and finally, let me just close with this. If you look at where networking has gone since Server 2008 and 2008 again, this is about your input. And this is what we've delivered in 2012. It's feature rich, it's extensible, and there's no compromises. You want NIC teaming, VLAN tagging, MAC spoofing protection, ARP spoofing protection, SRIO-V, networking quas, metering, monitor modes, IPSec, SRIO-V, all of this while still keeping live migration and giving you the best scalability in the industry. It's all here in Server 2012. I know we kind of whisked through a bunch of those things here, but that's very much what's been happening here in terms of the Server 2012 networking and switching. So understand that HyperV is fully integrated into the Windows network stack. Always remember, default to the synthetic network adapter. The only time to use emulated is for PXE. VLAN tagging, firewall rules for security, all there. Take a look at the new inbox NIC teaming. Again, it allows you to do all sorts of cool things. In fact, we support up to 32 NICs in a team. So if you got a lot of NICs out there, you can team them all, again, even from different vendors.
One final question I have. So we covered a lot of great virtualization features with HyperV. Which of these are available in HyperV Server?
Oh, great question. Everything.
HyperV Server comes with everything, right? No limitations.
I know.
No
I get this. Everyone's going to keep asking me, is this feature in there? Is this feature in there? Yes, this feature is also in the free Microsoft Hyper-V server.
All right, Jeff, thank you very much. And we will be back shortly after a break to cover Hyper-V storage.
Excellent. Thank you.